Good afternoon, class. Here's pre-calculus practice test number 4, covering chapters 8 and 9. And chapter 8, application of trigonometry, polar coordinates and vectors, part 2, polar coordinates and vectors. That's what we are covering now. Again, this is a pledge. Before starting the exam, we should know that we take the exam on our own. All right, given z equals 8, find the complex cube roots, reminding you of what we did as far as complex numbers are concerned. This is in the form of x plus yi or r cis theta. This is the polar format. Where r is square root of x squared plus y squared, tan theta is y over x. Z1, Z2 is R1, R2 cis theta 1 plus theta 2. In other words, if you want to multiply two numbers in polar format, you multiply their modulus, their magnitudes, and then you add up their arguments. If you're dividing R1 over R2, cis theta 1 minus theta theta, theta 1 minus theta 2. Cis means cosine and then I sine. The Moivre's theorem says if you want to raise it to the power of n, then raise r to the power of n and then multiply the theta by n. Now, if you want to take a root, so W is r cis theta sub 0, and it is larger than or equal to 2, there are n distinct complex roots. So z sub k is the nth root of r cis theta sub 0 over n plus 2 pi k over n, or 360 degrees k over n. In other words, either in degrees or radians, and k is 0, 1, 2, all the way to n minus 1. If you go with the next one, which is n, this will repeat, okay, because k becomes n, cancels this one. So what do we do now? W is 8 or 8 cis 0. In general, if you have a positive number, everybody, any number, 10 is 10 cis 0. Negative 10, 10 cis pi or 180 degrees. Okay, and the reason is very simple. Positive numbers, let's say 1, 2, negative numbers on the x-axis, negative 1, negative 2. So if you have any positive number, is the same value, the modulus, and then cis 0. If it's negative 10 in this case, cis pi or 180 degrees. Erase my one. And so having said that, we're going to put it in this format. So the nth root of 8, in this case, cube root makes it the third root of 8. Theta sub 0 is 0, 2k pi, or if we want to go with the degrees, it makes no difference. And because it's the cube root, then first of all, this 0, this goes away. Okay. And then you're dividing it by 3, and k is 0, 1, 2. Now, either 2k pi or 360 degrees k, makes no difference. So let's plug in 0. We get 2 cis 0. Let's plug in 1. We get 2 cis 2 pi over 3. Let's plug in 2. 2 cis 4 pi over 3. And you can go with, like I said, degrees or radians, makes no difference. Now let's evaluate each one. The first one, z sub 0 is 2 cosine 0, I sine 0. Obviously, this is 0, this is 1, so it's simply 2. The second one, 2 pi over 3. Remember, pi over 3 is the reference arc. In the second quadrant, cosine is negative, so this is negative 1/2. And sine is positive, square root of 3/2. So we're going to multiply by 2. We get -1 plus I square root of 3. And the last one, 4 pi/3. 4 pi/3. It's negative because in the third quadrant, both of them are negative. So this is negative 1/2, negative square root of 3/2. And so those are the answers. A quick recap. This is the way we find the nth root. Okay, so we need to know what is theta sub 0, and that means we have to put it in polar format. That goes pretty fast that way. All right, vector V has initial point P and terminal point Q. Write V in the form of AI plus BJ. Find its position vector, also find its magnitude. This is the notation for magnitude, where P with coordinates 3, 2, Q with 5, 6. So let's go over a couple of things. Here's a vector which has the initial and the terminal points with the given points. And that's actually, as you can see, it's parallel to that. And it's been moved such that the initial point, okay, is at the origin. So position vector, if V represents the vector AB, is an algebraic vector whose initial point is at the origin, then V is called a position vector. So this is not a position vector, becomes a position vector like that. Algebraic vector, we can write it as AI plus BJ or AB with the vector, format. A and B are called components of the vector. A vector with initial and terminal points given as such, P x1 and y1 and q x up to y sub 2 is equal to the position vector x sub 2 minus x sub 1 comma y sub 2 minus y sub 1. That would be the position vector. So it becomes a position vector if we basically put the initial point at the origin. So let's do that. So x sub 2 minus x sub 1, y sub 2 minus y sub 1. So 5 minus 3, 6 minus 2. This is 2, this is 4. Those are the components. Now, this is one way to write that. You can write it as AI plus BJ. So right away, this becomes 2I plus 4J. Or you can write 5 minus 3 times I, 6 minus 2 times J, and that is same. So there are two different ways of representing a vector in this case. Okay, everybody? So we have the position vector. What about the magnitude? Well, the magnitude of a vector is defined as square root of a squared plus b squared. Okay. So, and of course, the magnitude is always non-negative, greater than or equal to 0. If magnitude is 0, the vector must be 0. And the magnitude of two vectors that are opposite of each other are the same. And the magnitude of a times v, we can take the a out, the absolute value. And so in this case, square root of a squared plus b squared, so 2 squared plus 4 squared. This is 4. 16, they add up to 20. As you know, 20 is 4 times 5. 4 comes out as 2. 2 square root of 5. So a quick recap. How do we find a position vector, a position vector. So basically, we have the initial point, we have the terminal point. We move it such that the initial point is at the origin. How do you do that? You subtract the x coordinates and the y coordinates. 5 minus 3, 6 minus 2. This is a new vector. And they're considered equivalent. Now, how do you find the magnitude? The formula is very simple. The magnitude of a vector is square root of a squared plus b squared. That's how you find it. And so components, work on the components, square each one, and there you have it. Given v is negative 2i plus 3j and w is 5i minus 4j, find the magnitude of the v and then v plus w and 2v minus 3w. Just the way we would do algebra. First and foremost, the magnitude for the vector is a squared plus b squared under the radical. This is minus 2 squared plus 3 squared, right? Negative 2 squared, 3 squared. This is 4. This is 9. So square root of 30. V plus W. Add up the components. So we are going to add up these two, and we get 3i, these two, and we get minus j. 2v minus 3w, so 2 times v. So we're going to put the v vector here, and then minus 3 times the w vector. So distribute, just elementary algebra. Minus 4i plus 6j minus 15i plus 12j. Negative 19i plus 18j. So if you're adding vectors, this is u, this is v, okay? You go from the initial point of the first one to the terminal point of the second. That's how you add them up. U plus v plus w, and that's the case. So this is how you sum them up. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. Again, a vector is represented in a position. It's a position vector if it's x sub 2 minus x sub 1, y sub 2 minus y sub 1 with the initial point at the origin. Magnitude, we said is square root of a squared plus b squared. And as always, as far as the angle is concerned, b over a, consider the quadrant. So having said that, first thing first, magnitude. Square root of a squared plus b squared, which is 3 squared plus 3 squared. This is 9 and 9, 18. Is 3 squared of 2 because 18 is 9 times 2. 9 comes out as 3. So we got the first one. Direction angle. Well, reminding you, if you have a vector is the product of its magnitude and cosine of alpha I. That's this component along the x-axis, plus sine alpha j along the y-axis. The direction angle alpha is somewhere between 0 and 360 degrees. Okay, and it's the angle between the vector and the I, the x-axis, the positive direction of the x-axis. So we use tan of alpha equals b over a. And of course, b and a happen to be 3, both of them. That puts us in the first quadrant, obviously, because both of them are positive, and that is equal to 1. So that gives us 45 degrees or pi over 4. The alpha is 45 degrees or pi over 4. So we got the magnitude, we got the direction angle. And now we want to find the unit vector. The question is, what is a unit vector in the same direction? So this is now written as this one along with this one, 3 square root of 2 cosine of 45 degrees I plus sine 45 degrees J. The unit vector, excuse me, is the same vector divided by its magnitude. So V has components A and B. A times component 1, 0 plus B times component 0, 1, AI plus BJ. Okay, so as you can see, 1, 0 is the unit vector along the x-axis. 0, 1 is the unit vector along the j-axis, along the y-axis. And so all you have to do, V divided by its magnitude, which means we are going to use this one and divide by the magnitude. Make up 2 fractions and get rid of the 3. And I hope you know 1 over square root of 2 is the same as square root of 2 over 2. Because just quickly showing you 1 over square root of 2 times square root of 2 over square root of 2 is square root of 2 over 2. Okay, I hope everybody remembers that from algebra. So, what's the magnitude? Square root of a squared plus b squared, given v equals ai plus bj. What is the direction? Find the alpha using tan alpha is b over a, and just put the magnitude and cosine alpha I plus sine alpha j. What is the unit vector? Divide the vector components, each one by its magnitude, and that creates a unit vector in the same direction. Write the vector v in the form of a plus bj, given its magnitude and the angle alpha it makes with the positive x-axis. Find a unit vector in the same direction for the vector and check its magnitude to be 1. So the magnitude is given as 14, alpha is 120. Simply put it into this. Put it into this, everybody. So replace the magnitude with 14, alpha with 120 degrees. 120 degrees, the reference arc 60 degrees. In the second quadrant, sine is positive, cosine is negative. So cosine of 60 is positive 1/2, 120 make it negative 1/2. Sine of 60 is square root of 3 over 2. 120 is also positive because it's in the second quadrant. Again, I want to quickly write this, that reference arc is 60 degrees, everybody. So distribute the 14 and we get minus 7i plus 7 is square root of 3j. Now, that's that's the vector in this format. Now, we have this. Now the next one is unit vector. Divide by its magnitude 14. Obviously, you can drop the 7. That means you're factoring the 7. Okay, everybody. Minus 1 plus square root of 3 minus 1i plus square root of 3j. And we get minus 1/2 I plus square root of 3/2 j. We're done. But as far as checking means, find square root of a squared plus b squared is 1. So you don't even have to take a square root because square root of 1 is 1. So square this one, square this one. I hope you see this is 1/4. This is 3/4. They add up to 1. You want to take a root or you don't, that's fine, because either way is fine. You just show that if you square them, they add up to 1. And that's good enough. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. North east is this way. So this. The wind blowing from west to east, from west to east, this way, at 35 miles per hour. Approximate the ground speed of the plane to the nearest miles per hour and the true course of the plane to the nearest tenth of a degree. So what are we dealing with? What is the question? Let's find out. So going north 55 degrees east. So north 55 degrees is this angle east. If this is 55, this angle must be 35, everybody. So one more time, this is 55, this must be 90 minus that, 35 degrees. So velocity relative to air, the magnitude is given 200 miles per hour. And theta, okay, is 35 degrees. Remember, when we want to write it in this format, this angle is between the vector and the positive side of x. So let me actually do this. Okay, so this is the angle, this one. That's the velocity relative to air. And we know that the wind is blowing at 35 miles per hour this way. So this is the velocity with respect to air. This is the wind portion. So the magnitude, they said, is 35 miles per hour. And if they said from west to east, that means this is parallel to the x-axis, which makes a 0-degree angle. That's why it's 0 degree. Approximate the ground speed. Well, this is the vector that adds these two up. And we want the true course, which is this one. So the ground speed would be the magnitude of that. And the true course would be north, east, and in between is this angle, which is 90 minus this theta. So this is the angle. The magnitude we have to find miles per hour. North 90 minus theta. So that's what we are looking for. So let's write each one in this format so we can add them up. So VA is 200 cosine of 35 degrees I plus sine of 35 degrees J. And this one is simply 35 cosine. And by the way, you put that into a calculator, gives you that. For the other one is for the wind would be 35 cosine of 0 I plus sine of 0 J. As you know, cosine 0 is 1. Sine 0 is 0, so you get 35i. So we don't need a calculator for that. And so this one, the velocity with respect to the ground, we need to add these two component-wise. That means these two add up because they have the same component I. So 163.83 plus 35 is 198.83i, and this one, there is nothing to add to it. So we are adding these two, okay? So we are adding their components. So now that we have this, we are going to find the magnitude using square root of a squared plus b squared, that means square root of this number is squared 198.83 squared, and plus this number is squared 114.72 squared. Putting it into a calculator and roughly estimating it gives us 230 miles per hour. We can find this angle using tan of alpha is b over a. So tan of alpha is this number over this number. And you put that into a calculator, and theta becomes 29.98, let's say 30 degrees. So if this is 30 degrees, this that we want is 90 minus that, 60 degrees. Therefore, it's doing 230 miles per hour north, 60 degrees east. So a quick recap of what we just did, everybody. A plane is flying 200 miles per hour at this direction, everybody. The wind is blowing from west to east. So you connect them, and that is the new magnitude, the real magnitude with respect. The true, and we want to find the true course and the magnitude. So all you have to do, add these two. The way you add them up, you have to put them in this format to be able to add them up. So for this one, you need to find the angle. If this is 55 degrees, then this one, the blue one, is 90 minus that 35 degrees. This one, you know, is parallel to the x-axis, 0 degrees. So you write them with the components, you add up the two. Now that you have the two, you can calculate the magnitude using square root of a squared plus b squared. You can calculate the tan of alpha equals b over a. And when you find this angle, since they're asking for the true course, you have to say north, east, and in between, the angle is 90 minus what you just found, 30 degrees. That's how we arrive at the answer. So I hope everybody's okay with that. The dot product. The dot product of two vectors has many applications with the following algebraic definitions. We have vectors v and w and some scalar alpha and the definition. So the vector v is a1i plus b1j, or in this format, w is a2i and b2j, or this format. If we multiply them using the dot product, that simply means multiply the components a1, a2 plus b1, b2, and it becomes a number. The symbol v dot w is read v dot w. The dot product is also known as the scalar product or the inner product. The result is a real number and not a vector. Properties of the dot product. V dot w and w dot v is the same. V dot 0, 0 dot v is 0. V dot v is the magnitude squared. If you multiply it by alpha, you can put the alpha anywhere you want. V dot w is a1, a2 plus b1, b2, or the magnitude of v times the magnitude of w times cosine theta. Therefore, cosine theta is v dot w divided by magnitude of v times magnitude of w, or a1, a2 plus b1, b2 times that, where magnitude is square root of a1 squared plus b1 squared. So I hope everybody's okay with this stuff. Just definition, pretty much very straightforward. Here's a simple example. Finding the dot product and the angle between these two. V dot W is A1, A2 plus B1, B2. So 4 times 1 minus 3 times 2, add them up. This is 4. This is negative 6. They add up to negative 2. That's all. All right, we want to graph the vectors. This one, 1, 2, 3, 4 to the right, minus 3, 1, 2, 3 down. This one, 1 to the right, 2 up. So 4 minus 3, 1, 2, and those are the two. So it's easily graphed. Just plot the pair and connect it to the origin. That's all. So we got the, dot product. What about the angle? Cosine theta is V dot W over the magnitude as follows. Now, we have this as -2. What is this magnitude? Square root of 4 squared and -3 squared. What is this magnitude? Square root of 1 squared and 2 squared, according to the magnitude formula. So this is 16, this is 9. So you get 25, comes out as 5. 1, 4, it's 5. We're going to multiply by square root of 5 over square root of 5. So the numerator is 2 square root of 5. This is 5 times 5, 25. Again, if you want to rationalize, that's what you do, everybody, okay? So what is theta? Cosine inverse of this number. You put that into a calculator, and you get 100.3 degrees from, okay, so if we stop at this point, this doesn't change. Depends on how many decimals they ask you. All right. Show that the pair of vectors is orthogonal. Well, what do we mean by that? Orthogonal vectors. Two vectors are orthogonal when the angle between them is a right angle, 90 degrees. The dot product of two orthogonal vectors is 0. That means theta is pi over 2. So let's find the dot product. To find the dot product is 2 times 6 plus 3 times -4. This is positive 12, this is negative 12. They add up to 0, and that's the end of the story. We just proved they are orthogonal. Show that the two vectors are parallel. Okay. Parallel vectors. Two vectors V and W are parallel when the angle between them is either 0, the vectors point in the same direction, or 180 degrees, theta equals pi, the vectors point in opposite directions. In other words, V equals alpha times omega. One easy way, notice if I multiply this one by 2, I get 6i minus 2j, or in other words, W is 2 times V, or V is half of W. So if you multiply one of them by some number and you get the other one, doesn't matter positive or negative, that is the proof. That's one way to prove it. The second one is to go through that process and prove that. So Dot product 3 times 6 plus -1 times -2, that would be the numerator. Now, the magnitude for the v, square root of 3 squared plus -1 squared. The magnitude for w, the square root of 6 squared plus -2 squared. So basically, we use this. So this is 18, this is plus 2, this is 9 and 1 is 10, this is 36. Maybe I quickly write that. So as you can see, the numerator is 20 and the denominator is the square root of 400, which is also 20. And so theta is cosine inverse of -1, which is 0. A quick recap. Two vectors are orthogonal if their dot product is 0. Two vectors are parallel if the angle between them is, in this case, of course, the angle is pi over 2 or 90 degrees. In this case, the angle between them is 0 or 180. So you can put it into this formula and calculate that angle. It's that simple. Find the vector projection of v equals I plus 3j onto w equals I plus j. Decompose v into two vectors, v1 and v2, where v1 is parallel to w and v2 is orthogonal to w. Okay, so if you have a vector, you just cut them into two components. That's the concept. Now, to make some sense out of this, let's go over the idea. Vector projection. The component of V along W may be found by projecting the endpoint of V onto the line L containing W. For this reason, the magnitude of V cosine theta is sometimes called the projection of V on W and is denoted by projection of V onto W. A vector with the magnitude of component of V over W, V into W is a scalar. V1 is projection of V onto W, and that's V dot W over the magnitude of W squared times W. V2 is V minus V1, and component of V over W is just the magnitude of that. What do we mean by that? It's important to understand the concept as follows. Let's say you have a vector. If you drop a perpendicular, this part is a component along the x-axis. And if you drop it perpendicular to the y-axis, this is the component along the y-axis. That's the idea of having a vector and then two components. The two components make a 90-degree angle. Okay. If you have them this way, if this is the vector, drop a perpendicular this one and drop a perpendicular to the y this one. So these are the two components. By the way, the sum of the two components would be the vector. Now, if it's like this one, if you look at the red one, which is the weight, it's toward this, center of the earth because of the gravitational force, it is cut into two vectors. One is parallel to the ramp, one is perpendicular to that. So that's the idea, cutting it into components. So in this case, we can look at the graph. W is I plus J. So you go 1 unit this way, 1 unit this way, and you connect them. Now, in this case, two tick marks are 1 unit, okay? So one is here, one is here, just to give you an idea, okay? And then, so I want to make sure we understand that. So two tick marks is 1. Okay. And then I plus 3j, so 1 on the right, 3 up. So those are the two vectors. Now we want to find the vector projection of V onto W. So basically, drop a perpendicular. In essence, you continue, you make this a line. Imagine it's the x-axis. Onto this, imagine it's the x-axis. Make it longer and drop a perpendicular. So this is 1, 3. This is 1, 1. And V1 has this formula. We are going to evaluate it 1 times 1 plus 3 times 1. And the magnitude of W is 1 squared plus 1 squared under the radical, because this is 1 and 1. That's how we get squared of two quantities squared. So this is 1, this is 3, so this is 4. This is 2, we get 2W. So 2 times W, which is I plus J. So 2I plus 2J in essence. V2 is the vector minus V1, because remember the components, the two components add up to give you the vector itself. V minus V1. So V is this one, and V1 is this one. And I'm going to write I plus 3J minus 2I minus 2J. These two will give us negative I, the other two will give us positive J. So we continue on that, we get V2. This one is minus I plus J. Please understand, parallel to that, if you put it as a position vector, parallel to that, which is negative 1, 1. This is the same as this. Two vectors that are parallel in the same direction and they have the same magnitude are considered identical. Find the work done in pushing an automobile along a level road from a point A to another point B 40 feet from A while exerting a constant force of 90 pounds. Okay. Work is the result of a force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, we use calculus. Otherwise, work is simply force times distance. W equals FD. Well, force, for example, MA, if it's a weight mg, work WFD, which is magnitude of F times magnitude of D times cosine theta. And in this case, the force is 90 pounds, D is 40 feet, and W is simply FD, 90 times 40. And by the way, we are pushing it in the same direction. The theta is, in essence, 0, cosine of 0 is 1. So 90 times 40 is 3,600, and the units foot-pound. for this case. Okay, everybody? Joules. 1 joule is 1 Newton times 1 meter, or 1 kilogram, kilograms meter squared over per second squared. Joule, unit of work or energy in International System of Units, SI system, is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of the action of the force. Okay, James Prescott Joule. And it's equal to 10 to the power of 7 ergs, or approximately 0.7377 foot-pound, 1 joule. That's just the information if you're interested from physics. A child pulls a wagon with a force of 50 newtons. The handle of the wagon makes an angle of 30 degrees with the ground. Find the work done in moving the wagon 100 meters. It's important to understand the previous case. The angle was 0 degrees. Okay. So what is given? The force and the distance. So force is 50 Newton, distance is 100 meters, and the angle is 30 degrees. So we are going to go with this formula. W is magnitude of F, which is 50, times magnitude of D, which is 100, times cosine of theta, which is cosine of 30 degrees. And so this is 50, this is 100, cosine of 30 is square root of 3 over 2, and this is 5,000 divided by 2 becomes 2,500 square root of 3 joules precisely, everybody.